Because I remember, you let me know say I'm right or wrong. Okay, we are doing until the question 3, no? Now number 4. Am I right?
Yeah.
Uh-huh. Okay, number 4 is another questions about the graphic rational function, no? Entonces, in this case, the function is f of x equal x over x squared minus 16, something like that. Remember the famous 7 step, but not necessarily doing this way. This is it's a line guide, but you can do fast because you know the concept involved in any problem. For example, the first thing is factorization. The only possibility of factorization in this example is this is the difference of a square is xx44 plus or minus. Okay, no common factor that we cancel out, therefore no whole. Now, the next is find the y-intercept. Find the y-intercept is easy. It's evaluating 0, the function. And when you evaluate the 0, it's obviously 0 because it's 0 divided by 0 squared minus 16. It's 0. Therefore, when this situation happens, when the point is 0, 0, this point is both. It's x-intercept and y-intercept. But not necessarily happen because the only unique. Okay, maybe you have another, depending the nature of the polynomial at the top. For example, in order to find the x-intercept, well, the formula is easy. You take the polynomial in the top, so you take p, and you enforce it to be equal to 0. And in this case, it's the same because x equals 0. Again, we come back to the same point. So in this example, you have only one point is intercept. Is 0, 0 is both x-intercept and y-intercept. Empirical asymptote is super easy because you take q, que es el polynomial at the bottom, equal to 0. You take in either way. You take in this way or in factorial form. Either way. I don't know. I prefer, I don't know. It's not, I don't care. Anyway, it's easy. You solve this quadratic equation, apply square root both sides, x equal plus or minus 4. In this case, so far, the only information that we have in this moment is I like so much in this crucial moment I make a partition of the all real number line, and so far the information that we have is, look, we have, this is the x-axis, infinity positive, infinity negative. We determine 0, que es the x-intercept, and positive 4, 1, 2, 3, 4, 1, 2, 3, 4, negative 4. We have two vertical asymptotes. Vertical asymptote number 1 and vertical asymptote number 2. Everyone follow me so far? Because in the moment I need to pick arbitrary value, yeah, Jose. In the moment you need to pick arbitrary value to evaluate the function, because that's the last step, and this is important. You pick maybe 5, you pick maybe 1 or 2 or 3 or 4 below, because actually we have 4, negative 4, and 0, important partition. You take 1, you take negative 1, or why not, negative 3, and negative 5. This is a minimum number of points you plot, 4 points. In this example, no. In other example, it's different, of course. Okay, so now let's move on to the horizontal or slant. Remember to determine that you are doing the famous analysis of degree. Analysis of degree. The degree of the polynomial and the numerator is 1. Now we come back at the beginning. Degree of this guy is 1, linear. Degree of this is 2, que es quadratic. When this situation happens, when the degree of the denominator is bigger than the degree of the numerator, Yes, we have horizontal but special and y equals 0. So by the way, the point 0 is also x in a set, but it's also crossing point. It's obvious, right? Because my horizontal asymptote, let me use another color, maybe green. Yeah, green. I like green. It's something like that. It's coincident with the x in a set horizontal asymptote. The formula or the equation is y equals 0. And vertical asymptote, the formula of equation is x equal minus 4 and x equal positive 4. Okay, cool. Now be ready. Let's apply, for example, the symmetry idea. Symmetry. It's always the same idea. Remember, symmetry is special. The most common scenario is no symmetry. O sea, es neither. So whenever I suppose it works, dedicate a few seconds to investigate si es symmetry or not. Okay. Now it's easy. You make a reflection. You replace x for negative x in the original equation. So it says minus x over minus x squared minus 16. Wow. The bottom part stays the same because I know very well that when this is square, even exponent, the answer is positive. However, the top now is negative x. This, by the way, is equivalent to put this minus in the top and the front of the fraction. So when you compare this expression and our original expression, you see, wow, it's opposite side. A typical odd function. This is odd function. Therefore, you have symmetry with respect to the origin. And for example, so you evaluate at one point, for example, you evaluate fn1. I pick one, no? Remember. Well, it says 1 over 1 squared minus 16, que es negative 15. So 1 over minus 15. The point, at least one point in our graph is the point 1 comma negative 1 over 15. For sure, according to the symmetry idea, another point would be negative 1 comma 1 over 15, the same value but opposite sign. Because the action was, when you change x for negative x, so I change 1 for negative 1, the y value is the same value but the opposite sign. And you plot any point, and that's it. In this case, you have the handout for the review, no? I select the option D. Any question, guys? Do you understand very well or not? Come on. This is a review. This is a moment to ask me. No question. Michael Diaz. Okay, let's move into the next page. Next page. What is the next page? This is the next page. Okay, let me try to make a zoom. Oh, this is interesting. Look, number 5, no? Number 5 is a function is f of x, ooh, too much, is equal x squared plus x minus 6 divided by x squared minus x minus 2. Okay, as always, you know very well, the first step is factoring form. So you factorization the polynomial on the top. In this case, it's easy, not necessarily complicated technique of the scientific division. No, it's a classical factorization that we studying in intermediate algebra. So the combination is 3 and 2, no? 3 times 2, because 3 times 2 is 6, and somehow when you're subtracting or addition, in this case, subtracting, 3 minus 2 is 1, because the coefficient is here. Now I believe, or I suppose, que es opposite sign because it's subtraction, entonces one positive, que es the bigger, and negative. Likewise, in the second, the factorization, the combination will open the door is 2 and 1, no? Because 2 times 1 is 2, and somehow 2 minus 1 is again 1. But in this case, negative 2 and positive. Wow, I like that because in this case I saw that these factors cancel out. Therefore, I can understand very well that at x equal 2, we have a whole. And the representation for the whole in your moment look like that. It's a curve, but you put a hole. Hole is empty, totally empty, right? Okay, however, stay alive. So this equation, now I reduce it a little bit more clear like that. I delete, I cancel out the whole, but stay alive this factor, no? To say now, for example, in order to find the y-intercept, well, y-intercept is evaluating 0. It's easy. It's 3 on the top, 1 on the bottom is 3. So the point is the point 0, 3. This is our y-intercept. Our x-intercept is also easy because you take only the polynomial in the top. So you take p of x equals 0, and p of x is x plus 3 equals 0. Therefore, the answer is negative 3. So in negative 3, comma 0, we have the x-intercept. Only one. Okay, I understand that. Now the vertical asymptote. Remember, you take the polynomial in the bottom, q of x equals 0. And our example is x plus 1 equals 0. Then the solution is negative 1. Okay, now at this moment, I determine that we have only one vertical asymptote at x equals negative 1. So this is a crucial moment in which I spend some seconds to make the sketch how you like the x-axis in our function. Okay, this is all real number, infinity positive, infinity negative. Okay, we have in my hand 3. Well, let me set up 0, 1, 2, 3 positive. Okay, this is the x-intercept. Look at that. No, it's negative 3. Oh, mistake. Negative, sorry. Okay, no problem. I erase. Negative 3. Negative 3. This is the famous x-intercept. And in negative 1, we have the vertical asymptote. If I need to select totally arbitrary value, well, I select in between negative 3 and negative 1, I like negative 2. Before negative 3, maybe negative 4. After negative 1, maybe 0. Well, 0 I did get 3. Pero suppose another. To complementary more. 1, or 2, or 3, or 4, or 5. So 1, you pick one value representative of the interval que after they determine the x-intercept and vertical asymptote and create the partition, you have, I don't know, in this example you have 2 partitions, so we have 3 intervals. I pick at least the minimum amount of value is 3. Okay, entonces let's move on to the horizontal or vertical. Or slant, I no idea. Horizontal slant, remember this is the duality. Or you are horizontal, you have horizontal, or you have slant. Mutually exclusive, one of these, not both. And vertical is totally independent, it's another word. Now I go to the function. Of course, the function in lowest term. Entonces now you are doing the famous degree analysis. Degree of this polynomial 1, linear. Degree of this polynomial 1 is linear also. Okay, same degree. Entonces I know very well that yes, we have horizontal at horizontal at y equal 1. Because it's the division, this number divided by this. Okay. Entonces now, as always happen, I need to investigate if we have crossing point or no. Guys, this is mandatory, crossing point. Some people, no, I don't like, well, you don't like, but it's mandatory. The crossing point is the point, the virtual point, the hypothetical point in which our function is this. Should be equal 1, que is the value of the horizontal. Okay, so now cross multiplication, x plus 3 times, well, 1 is whole number, I suppose it's 1 over 1, so multiply this and this, multiply this and this, is equal to x plus 1. I try to do my best for solving this equation, but it's obvious that this equation is impossible solving because I have no solution. Okay, but no, suppose I don't know, no. Okay, you try to group in the x in the left part. You try to group in the number without variable to the right part, 1 minus 3, and x minus x is 0, and 1 minus 3 is negative 2, and you get totally false statement can indicate. So the interpretation is we have no crossing point. So the curve never crossing the horizontal axis. And this is, by the way, this is the most popular idea. It's a frequently idea. So it's very, very seldom it happens que the curve crossing. But okay, I need to investigate. Okay, and the other slider, I select in the handout the option, option D, I guess so. It's important, guys. It's important. Yeah. There you go. Look at that. I see it now. Here, D. Of course, in the test, we have no multiple choice. But in the handout, yes, because I want to verification that we're doing well. It's obvious D. The reason is you see clear the vertical axis in -1, you see the horizontal axis in 1, +1, and you see the famous hole here. Okay, you see the hole. Another curve have no hole. This is the answer. Any question? Any question? Come on, this is the review. In the review, you can ask me any question. Please don't hesitate. I enjoy. Nope, all clear. Mister.
How would you calculate? How would you solely look for the hole within a graph?
Remember, step number 1 is factorization the polynomial in the top and factorization the polynomial in the bottom. I did that here. Look, we come back to that part. Now you factorization, and you see, wow, the factor x minus 2 is canceled. Therefore, that indicates us that the whole is at x equal to. Okay?
So at that point, whatever gets canceled indicates where the hole is at?
Exactly. No doubt. Super clear. The fact that it's gone, cancel out, is a hole. The fact that stay alive, the stay alive and the denominator is the vertical asymptote, and the fact that stay alive and the numerator is the x intercept. Make sense?
Yes.
Yeah, absolutely. Oh, I lost the paper. Where I put the paper? I don't know. Yeah. No. It's this. Sorry, it's this. But let me erase that part. I need to organize a little bit my web work. A little bit, not too much. Okay, we focus on that page. Okay, that page. Let me erase that part. Okay, now we change the flavor. Now we working with the inequality, polynomial inequality. Number 6 question say, x to the 4th power less than 9x squared. It's a typical polynomial, okay? And remember, extremely important. To solve any inequality, polynomial inequality, or rational inequality, mandatory, guys, you need to manipulate the expression in order to express the right-hand side like a 0. So you copy x to the 4th power minus 9x to the 2nd power less than 0. This is super important. See, I don't see that, I suppose that you never get the answer. Now, after that, you are doing factorization. Factorization, the left-hand side. The greatest common factor is x squared. We have x squared minus 9. But I don't finish the factorization because I saw that we have a difference of a square. It's xx33 plus or minus. Okay. This is my new expression, okay, by the way, is totally equivalent to the original inequality that nobody understands. But now it's clear. How you clarify that? You find the critical value. Critical value is, you suppose temporary, okay, this is equation. And you see, okay, x is 0 is one solution. X equal minus 3 is another solution. And x equal positive 3 is another. And this is the critical value. And the critical value helped me to make a partition of the real number and after the selection of the testing point. Okay, this I want to see, and the answer you send me by email, I want to see factorization, moving everything to the left, right hand side must be 0. I want to see one important part I consider important, okay, doing the graphic part. Okay, the graphic part, we have all real number. Entonces we have 3 partition and 0 and positive 3. Yeah, negative. Somebody have the microphone open. Please put it off. Thank you. Now you pick arbitrary, totally arbitrary. We have 4 intervals, 3 partition, 4 interval. You pick, for example, my paper. I pick negative 4. Okay, representative of this interval. I pick negative 1. I pick positive 1 or 2. Either way, that doesn't check answer. Okay, after the selection of the testing point, you are doing your famous table. Guys, this is not strictly mandatory. Some people, some students want or lie, or another teacher explain different. You plug in negative 4, negative 1, 1, and 4 into the inequality, and you compute that. In my opinion, it's easy doing step by step because the computation you can do mentally, not necessarily calculator. It's easier. Entonces now, wait. I forgot one important. The factor actually is x squared, x plus 3, and x minus 3. Pero no, because I detecting que the factor que contain even exponent que is always positive, not necessarily included inside that. Ahora, be careful. It's not too easy. Remember que there are 2 categories, totally delete or partial delete. In this case, obviously, is partial delete. Because my problem, let me see, eraser, a partial. How do you know the partial? Because my inequality is a strict inequality, no equal sign here. Si es equal sign, yes, you totally delete. Pero no, es equal sign, no equal sign, sorry, therefore, a partial. So, what if you think I try to explain? I try to explain that you don't care too much this inequality because you can solving this inequality less than 0 under the consideration, be careful, that x not 0. And this is because it's partial delete. See, this is equal, not necessarily a specification of the restriction. In the table, you put only 2 factors, x plus 3, x minus 3, and end the story. It's a total. I listing vertical -4, -1, +1, and +4. Guys, by the way, we are recording or not? Let me check. Yeah, we are recording. You are the best. I have assistant, anonymous assistant, but some students help me in this. Okay, entonces now it's negative. I suppose you understand very well where come from this negative. No, -4 here, -4 +3, and -1. But I don't care about it. I care the sign only to solve the inequality. If negative, 2 negative is positive because it's multiplication. The thing I enclose in the circle is because the important information is the last column, and it's a partial. Okay, now entonces -1 plus, minus, is minus. And +1 is plus, minus, oh, it's the same, minus. And 4 is plus. Que es obvio que es plus. However, I come back at the beginning, my inequality is less than 0. The true, guys, is the negative. So this is true. So when you plug in the -1 into the inequality, suppose I am doing no by factors, I do complete it, I get negative value. Get true. Entonces, this is the moment to highlight the interval que pass the test, que es this. Let me make it zoom, let me put more intensive. This interval and this interval. Ahora, be careful, the tricky part. What happened with the endpoint? No included. Definitely no. No 3, -3, sorry, no +3, and no 0. And it's logical because in 0, remember, we have a whole. So what is the answer of this problem? Well, the answer is from -3, 0, no including -3, no including 0, no, union, because we have two pieces, 0, 3. So by the way, is the option B in the handout. Any question, guy?
Professor, I have a question.
Go ahead.
How do you know which one is true or false?
You see in the original inequality, you have that symbol, less than. Do you see? And also, when you manipulate, in order to express the right-hand side 0, you have less than. And to be less than 0 is synonymous, is the equivalent to be negative. And negative guy is the good guy. And positive guy, no, it's no solution. Clear?
Yes.
Super. Okay, so let's move on to the question 7. I can erase that part of the board or not yet? Let me know. I can erase or no? Not yet? Well, no. Okay, sorry. No erase. Okay, no problem. Let me know when you finish the copy. Or maybe I'm using another part of the board. Yes, you can. Okay. Cool. Let's move on to number 7 now. 7 is similar. Yes, Kiana. Okay. 7 is x to the 4th power minus 21 x to the 2nd power minus 100 greater than 0. You see, in this example, is greater than or equal to 0. So I take advantage. Wow, nice. Okay, right-hand side is 0. Entonces, ese es strict inequality, no equation, no equal sign, no. Entonces, es obvio que this is equivalent to say que when I fill it in the table, I select the positive. Because to be greater than 0 is synonymous to say que es positive. Okay, so I focus on the factorization. The factorization, the trinomial is square root this guy que es x squared. And try to find the combination. Okay, open the door. We have 100 to 25. 25 and 4, no, because 25 times 4 is 100, and 25 minus 4 is 21. and the sign are negative here and positive here. I finish? No. No, why not? Because we have a difference of a square here. Okay, I factor completed like that. X, 5, 5, plus and minus. Okay, done. And here, no, because this is irreducible quadratic. So in the complex, in the real field, you cannot factorization this because it's the sum of a square. And the complex, yes, you can, but no, I don't care complex because remember, my solution is on the real field. So the line I draw is already a number. The imaginary is another plan. Okay, entonces now, for sure, 100% guarantee you que you can omit that part. Totally. Entonces the question can fly in the air. Why totally, professor, and not partial? Because this is a parabola. Look, it's important to understand that we have two kinds of parabola. You have this kind of parabola, but not exactly like that. You have one kind of parabola, suppose. It's a 4. And this kind of parabola is different. It's here. Okay, it's 4. 4 in the y-axis. So that point is the point 0,4. That point is the point 4,0. So be careful with the partial delete or totally delete in this scenario. Okay, the factor is x minus 4 squared. But this no, this is x squared plus 4, que is always positive. You see it's all over the x-axis. It is lie in the positive parts. Therefore, you can delete totally. Remember, the positive is not important in the solution for the inequality. In this case, no, be careful because it's 0. And so now to don't get contradiction, if my inequality do have no equal sign here, so you need to exclude this, the 0. But it's okay. In this case, you can delete totally because this is similar to this. Okay. Now I focus on the solution of this elementary inequality. Well, okay. Actually, we have two critical values. -5 and positive. Using this critical value, I make partitions. And the partition, guys, I say several times, I want to see the graphic part. The table is optional. So you like the table, you are doing the table. So you don't like, no problem. You evaluate directly in the inequality. Entonces, suppose que dice 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, -5. We have two partitions. Therefore, we have 3 intervals. The selection of the testing may be, I don't know, f -6. S0 maybe. I like 0 because 0 is easy to evaluate and positive 6. If you are doing the table, TP, the testing point I declared was -6, 0, no, 0, no. Sí, 0, yes, sorry. Positive 6. So 0 is testing, no critical. The critical is a -5 and +5. And the factor I want to put in the game is this factor and this factor. It doesn't matter, the order is not important. And remember, attach one extra column in which you condensing, summarize the information of the signs. So negative, we got -6 plus 5, -1. And -6 and -5 together is -11. Double negative positive. 0 is positive. 0 is negative. Entonces the sign is negative because positive times negative is negative. In this case, time because it's polynomial. The multiplication. And 6 is positive. Positive. Okay, and come back again at the beginning. I see that our inequality is greater than 0. And greater than 0 is equivalent to say to be positive. The true guy is this and this. True. So when you plug in -6, the answer is true. The statement is true. When you plug in 0, no, it's false, it's negative. And when you plug in 6 positive, it's true. Now the solution of the hour inequality is this interval. Of course, you're extending to the negative 5, get the critical value. Negative 6 was totally arbitrary point I select. But another student select negative 7 or negative 8. However, the critical value never change. This is the solution. And what about the endpoint? Include or no? No include. Why not include? No include because our equation have no equal sign. Equal sign, yes, include. No equal sign, no, no include. Then what is the final answer? The final answer is from negative infinity, comma, negative 5 parenthesis, union, positive infinity, comma, infinity. Positive 5, sorry, comma, infinity. That's the option D in our handout. Any question? How do you feel in that part? You have to practice. Okay, you are doing it. Jose Cabrera are doing all the homework and get 100 points. This is Jose Cabrera. Okay, however, the other student can do the same idea. Do the homework. Remember, it's 10 extra points, guys. The homework. Shana is included. We use in the bracket. See, Shana. If you have the problem like that, is equal, of course, this is a bracket. Bracket here and bracket here. But no, this is another problem. My problem in this. But you need to be aware, of course, to face any problem. Chain, okay, thank you, no problem. So who determines if bracket or parenthesis? The endpoint is included inside the solution or no? See, our inequality is strict inequality, no the combination inequality and equation. Es obvio que no. Okay, let's move on to the question 8, que es super easy. Wow, it's super easy. Es, okay, look. What happened with the x squared plus 4? Good question. X squared plus 4, mister. You need to know that this is irreducible quadratic. In other words, no factorization that part, at least in the real field. Okay, and the interpretation is this parabola like I explained before. This parabola is always positive. This is always positive. You can delete totally this element. This idea is clear or no for you? I can explain in a different way, no?
So we just ignore the x squared plus 4.
X squared plus 4 is the factor que have no 0 in the real field. No, it has 0 in the complex. In the complex, I don't care. One interpretation is, this is the parabola, it always is positive. Makes sense that it's always, regardless the x value get plugged in, because you square any number positive or negative, when you square becomes positive. Plus 4, more positive. So this factor always is positive, and the positive factors never participate in the game of the inequality. This idea is clear? Clear. Sure, clear?
Yes, thank you.
Excellent. Okay, let's move on to number 8. It's super easy. So number 8 is giving one polynomial, que is f of x equal x cubic plus 2x squared minus 6x plus 8. So this is a typical notation. You put semicolon and x plus 4. So the thing is, I try to investigate if the factor x plus 4 belong or not to the polynomial. There are many ways to do this. I want to do it in 2 different ways, and you make a decision what way you prefer. I am fan to the synthetic division. Okay. Synthetic division, so you select doing by synthetic division, you put the format for the synthetic division, you put the coefficients, 1, 2, negative 6, and 8 positive. And you put here negative 4. Be careful. This 4 comes from this 4, but in the factor idea is x plus 4. However, the 0 idea, The zero idea is x equal -4. Make sense? Keep in mind that in our scientific division is -4, so you change the sign. Okay, so you apply scientific division, two very easy, and you now plug in, want to bring down 1 first without do anything. Multiplication 1 times -4 get -4. We combine here get -2, and -2 times -4 is +8, and you combine the third column with negative, no, negative, positive 2, no? Positive 2. And now you multiply +2 times -4 is -8. Wow! Yeah, I discovered that when you add it in the last column, the remainder is 0. That means get the factor x plus 4 below to the polynomial. Clear? The answer is yes. See, the answer here is another number, not 0, to say the answer is no. It's easy. It's easy and powerful. Scientific division is super powerful. Let's practice number 9 and number 10, and you see surprise. Number 9 is f of x equal x to the 4th power plus 12x to the cubic power plus 4 x to the second plus 40x minus 96 semicolon x minus 12. So I do it by scientific division. And scientific division, you copy the coefficients, get 1, 12, 4, 40, and minus 96. And you divide it by a positive 12. It's the opposite sign of the factor. Because actually this is the 0. Bring down 1, multiplication 1 times 12 is 12, and 12 times 12 is 24. Wow, just I see that something is totally, Jasmine Norris meeting is 0. It is 0. No, in this case, no. In this case, not 0. Yeah, when you see it, for example, when you multiply 24 times 12, it's 288. This divergent. You never reach 0. And when you multiplication, wow, it's a huge number. 3,504. Together is 3,544. And multiplication again, wow, diverging. It's a whole huge number positive and never is 0. It's 528, and when you put together subtraction, it's 42,432. Entonces now that number is not 0. Therefore, the conclusion is no. The factor x minus 12 don't belong to this polynomial. Guys, do you understand the idea or no? Okay. Let's do it number 10, que es similar. It's similar, it's more complicated because it's degree 6 polynomial. O sea, es x to the 6th power minus 13 x to the 4th power minus 52 x to the 2nd power plus 64. Semicolon, and you try to prove that x minus 4 belong or not to the factorization of this polynomial. And in this case, tricky because some monomial is missing in the polynomial. Entonces, my recommendation is to guide me and don't fail. You put x to the 6, x to the 5, x to the 4, x to the 3rd, x to the 2nd, x to the 1, and x to the 0, degree 0. And you put 1, que es the coefficient here, pero 5 is missing. This is missing a 0. Now, negative 13 cubic is also missing. Minus 52, x along linear degree 1 is also missing 64. And you put it here positive 4. Do you understand this idea or no?
Yes.
Okay.
Yes.
Okay, so let's do in the scientific. It's important, guys. You omit O sea, si one value is missing in the format of the scientific division, you declare it like a 0.
Professor, thank you.
Uh-huh.
If we wanted to, is it possible to do this with long division as well?
Yeah. It's the same. Okay, what is the difference, mister, between long division and scientific division? It's the same thing. But scientific division bring me like shortcut because you omit the variable, it's just numerical. But be careful. Long division is universal. You can divide any polynomial divided by any polynomial. Doesn't matter the degree. Scientific, no. Scientific is particular, in which you divide any polynomial, but divide only by linear polynomial, degree 1. So you apply only when the degree of the denominator division is 1. So in this case, x minus 4. So the action that we are doing is divide this polynomial divided by, so in the format for the long division, you are doing differently. You are doing x to the 6th power minus 13, x to the 4th power, minus 52, x to the 2nd power, plus 64, and you copy here x minus 4. And you start division. Bam, 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 bam. So you like it's okay. Disadvantage of this is too long. Also, you need to multiplication and subtraction. So any monomial, suppose that the first one is x to the 5th power, because x to the 5th times x is x to the 6th power, and you change the sign and multiplication this and this. But entonces now, bueno, when you multiplication is minus 4x to the 5th power, and you change the sign to positive, no? But this and this don't like is no like term, and you copy in the next line differently, in different position. It's the same of this, but this is more organized, in my opinion. I respect any opinion, no? Okay, so bring down one, multiplication 4. 4 plus 0 is also 4. 4 times 4 is 16, positive. This is 3, positive 3, 12. This is 12. 12 plus 0 is 12. Time 4 is 48. Subtraction is negative 4. I got it. Okay. I got no for an answer. Now multiplication is 16, no, minus 16. Minus 16, you combine minus 16, and minus 16 times 4 is minus 64. Again, it's 0 remainder, therefore the answer is yes, according to the zero factor theorem. This is the application of the zero factor theorem. Okay. See, this is 0 is because the factor belongs to this polynomial. See the remainder no 0, entonces no. Super clear? Yes or no? All right. Yes, he said. Do you see, guys, I sent last time to link the link of the current video last time, plus another link that is the solution for this package? Do you see or not?
Yeah.
You see that there are
Yeah,
seven.
I saw it.
Well, okay. Entonces, you no problem. You watch the video and you get 100 points in the test. Okay, I finished that page. Let's move on to the next page. I don't know what is that exactly. Let me see number 10, no? 11 now. 11 now. I delete that part. Delete, erase, erase. Okay. Come on. Okay, erase. Now 12, no? We are doing 12. Let me try to find 12. Oh, there you go. I suppose it's this, no? Oh, no. Let me see. Let me enlarge the page. Yeah. This is 11, no? 11, yeah. 11, 13. Okay, cool. This is the Descartes rule. The Descartes rule is super easy. The Descartes rule. Let me try to do 11. Look, 11 is a polynomial. The polynomial is minus 6 x to the 9 power, or degree 9, plus x to the 5th power, minus x squared plus 7. So what is the analysis? So you remember that the fundamental theorem of algebra say that if the degree of the our polynomial is 9, we have a total of 9 zeros. And this 9 zeros include repetitions, multiplicity, different to 1, 2, 3, 4, 5, and the complex. Okay, the complex, by the way, is coming by couple of the so it's coming by a pair, like a conjugate, no, a husband and wife. I don't know who changed that. Zoila Marie Garcia, no? Zoila, are you there? Zoila. Okay. She's sleeping, no? Okay. This is the problem of the online class. Okay, entonces now, let's do it. Remember the Descartes rule, determine P and M. P and M. What is P or what is M? Well, P is the amount of the positive real zeros. Or the possibility, no? Not always is completely true. And N represents somehow the negative. So now you understand, or try to understand, the number of chain of sign. Look, this guy is positive and chain to, this guy is negative, sorry, and chain to positive, positive to negative, and negative to positive. Actually, P is 3, because you see 3 change of signs. So that's the rule of the Descartes, that was created before Christ, is you subtracting 2. 3 is 3, or is 3 minus 2 is 1, and that's it, 3 or 1. Because 1 minus 2 is 0. Now, to understand the negative part, well, the only thing you should do is make a reflection. It says 6x9, so the exponent odds change, and the exponent even no. Stay the same. Of course, 7 stays the same because you can interpret it like x to the 0 is even. I don't understand the plus part. The plus part, Mister, is easy. Yes, to determine the plus part, you subtracting P minus 2, P minus 4, and so on. Until when you stop when you get negative number. The negative number have no sense. So 3 minus 2 is 1. No, 3 minus 3, P is P. P minus 0. Que es 3. Entonces, 3 minus 2 is 1. 1 minus 2 again is negative 1. So no. It's 3 and 1. Do you understand or no? I suppose that I don't explain very well, no? No. Okay, look, it's easy. Their thing is super easy, but it's weird. I understand this. Okay, Miss Norris, take a look. Descartes say, not me. To find a positive, you take P, subtracting 0, P subtracting 2, P subtracting 4, P subtracting 6, bam, until you stop when this number is negative, it has no sense. So P is 3. 3 minus 0 is 3. 3 minus 2 is 1. 3 minus 4 is negative 1. Oh, no sense at that part, and no sense at that part. I take 3 and 1. It's exactly the same right here. 3 and 1. Make sense? Now it's clear? Yes. Now the negative part, first of all, I need to make a reflection. Look, I try to explain the reflection. The reflection is I change x for negative x. Entonces, thank you, no problem. This is minus, this is positive 6, x to the 9, minus x to the 5, so the exponent gets odd number change. The negative no. 7 state. Let's you want to investigate the change of signs, and this new polynomial after the reflection. This is positive to negative, 1, negative to negative, no change, 2. And the rule is the same. You F2 was 0, because you subtract S2 minus 0 is 2, 2 minus 2 is 0, and of course 2 minus 4 is negative 2, is negative and have no sense. What is the fantastic conclusion? The fantastic conclusion is the number of positive potential, no, is 2 or 0. Let me see. I make a mistake here. Sorry. The number of positive is 3 or 1. And the number of the negative is 2 or 0. Okay, super. If you want to see more clear, normally in the lecture, we are doing the charts like that. Let me try to do 3 rows. Positive, negative, no, sorry, positive, negative, positive, negative, complex, and total. Total I know is 9, because the degree of the upper polynomial is 9. So any possibility ending in 9, 9, 9, 9. However, we have different possibility of P, 3 and 1, 3 and 1. The positive. And the negative is 2 or 0, 2 or 0. I suppose that we have more possibility, because 3 and 2, 3 and 0. Let me copy differently. I want to copy, this is extra, guys. The answer I get, the answer is this answer, and this answer. So the number of the positive 0 is 3 or 1. Positive real 0, real, we're talking about real. And the number of negative real is 2 or 0. So we have 2 or nothing. Entonces 3 and 2, 3 and 2, 3 and 0, because you match in that combination and this combination. Okay, and 1 and 2, maybe too complicated. And 1 and 0. It's 9 and 9, no? Always. I suppose we have 4 combinations. Entonces 3 plus 2 is 5, minus 9 is 4. So 4 complex is 1 possibility. Possibility number 1. I need to investigate more. This is 6. 3 plus 6 is 9. And this is 6 again. And this is 8. 8 complex. Remember, important, the complex always is even, because coming by pair. But the answer for that question 11 is D. D que es degree 9. Look at that. 3 or 1 positive 0 and 2 or 0 negative 0. Super clear or super confusing? Huh?
So that's the first row.
I don't know. Exactly, I don't know. I need to investigate more. How you investigate? Using the rational factor, the rational zero theorem, and after I am doing several synthetic division. By the way, I do in my graph in decimal to investigate But the equation is given. To say now, finally, after this long work, I have conclusion. That well, this is only a clue to continue in the investigation. But no. According to the question, you stop here. Remember exactly the example, the big picture example that we are doing in the, of course, in the test, I asked you a specific thing, not all of them. 12 is similar. 12 is y equal, or f of x either way, 8 x to the 8 minus 4 x to the 7, plus x to the 6, too much. Minus 4x plus 8. Now I investigate P. Es obvio que P es 1, 2, 3, and 4. 4 change sign. Therefore, the number of positive is 4, 2, or 0. Remember, you're subtracting 2, always, until the number is negative, and you stop. Now you make a reflection. When you make a reflection, is 8x to the 8 stay the same, 4x to the 7 no change, reflection, so the 6 power stay the same because it's even, plus 4x is change, and 8 stay. Entonces you see, wow, no negative, no change of sign, sorry, n is 0. Now the number of negative of this polynomial is 0. The conclusion is, okay, to answer that question is no super complicated. Degree of the polynomial is 8, and the number of positive is 4, 2, or 0, and the number of negative is, we have none. Okay, in my opinion is the option A, no? Let me check it out. 8, 4, 2, or 0, positive 0, and no negative. Excellent. Option A. Is now clear, guy? Answer, say something.
Yeah.
Excellent. A ver, opinion, Alison dice que yes. I am so proud of this class. I enjoy teaching. This subject is nice, guys. Nice, no, it's hard, but this is beauty, and this is the base foundation for the take calculus. Okay, this is the reason que deben explicar. ¿No? Okay, entonces the next example is 13 is x to the 6th power plus 4 x to the 5th power plus 4 x to the 4th power, too long, plus 3 x cubic minus x squared minus 5x plus 4. If I want to find P, I saw positive, one change sign, negative, one change sign. So P is 2. Therefore, si P is 2, the number of positive is 2 or 0. 2 minus 0 is 2, and 2 minus 2 is 0. And what about M? Well, before doing M, I need to make a reflection. X to the 6 minus 4x to the 5th. Remember, one more time I explain. The exponent odd change, the exponent even no. Plus 4x to the 4th power minus 3x cubic minus x squared plus 5x plus 4. So the number of negative then is, this is positive, negative, this is positive, negative, negative, stay negative, negative, positive, and stay. Actually, it's 4, no? And it's 4, and the number of negative would be maybe 4, 2, or 0. Subtracting 2, always subtracting 2. Es the option C. At least I have in my paper. Option C, que es degree 6. Nice. 4, 2 or 0 positive 0 and 2 or 0 negative 0. It's cool. How do you feel? Strong in that part? Descartes rule. Ese rule. In my opinion, very useful, but it's just a rule. And you apply the rule of this game, que es called Descartes rule. Okay, let's move on to the 1415, que es the rational. The word rational indicates fraction. Rational zero theorem. And remember the famous formula, plus or minus p divided by q. P divided by q. And who is p? P is the coefficient of the degree 0, and q is the coefficient of the higher degree. O sea, suppose a polynomial que es 6x to the 4th power plus 3x to the cubic power minus 4x to the 2nd power plus 2. And then who is p? P is 2. Who is q? Q is 6. Okay, so we have plus and minus, and you break it down any possibility. Any possibility is, in the top we have 2, no, this is 2 and this is 6. And you put plus or minus 1 and plus or minus 2. We have only 2 possibilities. I saw that he did alphabet. No, in this case, no reflection. No. You confusing both theorems. And this is not necessarily Miss Norris, no reflection. Only you tell me P and Q and end the story. This is 6. And the last one.
Yeah.
I erased, sorry. I did that, for sure. You want to see in the video. Guys, you let me know if I do it too fast, but it's the review. I suppose que you know, no? Entonces now 6 is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Do you understand this or no?
Yeah.
Okay, entonces what is the list of the hypothetical zero, rational zero? Okay, it's important to understand that these theorems do not guarantee the existence of this zero. Maybe you spend 3 hours doing this, and when you finish, you have nothing. So not necessarily. If exists the rational zero, okay, I repeat, the word rational indicates fraction, or whole number, or decimal, pero no irrational. Entonces, si exists, the rational is inside this list, pero no necessarily the theorem guarantees the existence of this. So the combination is plus or minus 1, plus or minus 2, plus or minus 1/2, plus or minus 3 1/3, and plus or minus 2/3, and plus or minus 1/6. Where I come from that value? You take the first and the denominator, and you split like that. Okay? Es 1/1, que es 1, and 2/1 es 2, no? I suppose you understand that part, right? Now you take the second, and the second with this and this. It's 1/2, is this, and 2/2 again is 1, but I don't need to repeat again. No. But this is the list. The property of the list is that no repetition is allowed. It's the same stupid value. I don't want to repeat. Now, what about the third? The third is you take 3 with 1 and 2. It's 1/3 and 2/3. Do you follow me? Do you follow me? Do you understand where I come from the list? How you form the list? Yes, Giselle. Okay, entonces now in that example 14, the answer is B. That one. Not necessarily in the same order, no? Okay, we create. But the list is important two important property of the set, no? Is no repetition allowed, and the order is not important. It's the same list. Cool? Cool? Rebecca, relax. Okay. May I erase the board? Oh no. This is easy or no? Cool, cool, Jose Cabrera. Okay. 15, no? 15 is similar. 15 is y equal minus 4x to the 4th power plus 3x squared minus 4x plus 6. Let me check it out so I copy well or not. Yes. Okay, this is a p and it's a q. By the way, I don't care the signs. Why not? Because in the formula you put plus and minus p divided by q. So default, you suppose two possibilities, positive or negative. So not necessarily, q is negative 4. No, q is 4. And you break it down. So you put in the top p, que the combination for p is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. This is the combination that somehow generates 6, because 1 times 6 is 6, and 2 times 3 is 6. Okay? And 4 is easy, it's plus or minus 1, plus or minus 2, and plus or minus 4, no? Because 1 times 4 is 4, and 2 times 2 cannot necessarily repeat 2 and 2 times, no. And the list, when they format the list using the same idea, same criteria, is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, this is the answer when you consider the first number in the denominator, and the second is plus or minus 1/2, plus or minus 3/2, because 2 over 2 is 1, no, and 6 over 2 is 3, I have 3 in the list, and the last number is 4, sería plus or minus 1 over 4, 1/4, and plus or minus 3/4. Is the option D in this case. That one. Now, guys, this is just the beginning. So you want to do the big picture problem, you need to take now one by one. He applies synthetic division, and you spend maybe 2 weeks doing this problem. But no, in the test, only specific question. I suppose that someday you need to work with this. You put in decimals, and then you see clear using your eyes, where the zeros are least real, because in decimal you see real, no complex, and you have a clue to start doing synthetic division several times. And when you are doing one synthetic division and you get 0 remaining, you obtain one new 0, and the degree of the polynomial is reduced. Suppose that the degree of the original is 4. When you perform one synthetic division successfully, you have degree 3, another degree 2, and another degree 1, and I finish. Break it down, the polynomial without factorization, so using synthetic division. Do you understand very well this idea? This is a central idea in this chapter. Cool? No problem. Of course, guys, I am aware it's not enough the lecture and not enough the review. You have to work by yourself. It's the only way to learn something, working by yourself. Remember, I can help, not too much, but I can help a little bit when you are doing the homework and you stuck in one problem. Of course, you email me. You send me the screenshot of the specific problem. Remember, any problem is different to any students. It's the same objective, but different numbers. It's different to my platform. In my platform, I cannot see your work. Well, I can see your work, but in the grade book, when you finish, you get 95, 85. Okay? But I don't know. See, okay, some complain because you are doing well. Remember, Alex is a robot. The Alex, when they grade, compare the hypothetical answer they have in the database with the answers. If they are not matching, entonces now he don't eat because it's a robot. Grade wrong. However, you claim me, Professor, I did well. Yeah, I checking. I go inside your test when you finish, of course, when you submit. And I understand that you are right. Yeah, I put a point. End the story. Okay? Don't hesitate to make a complaint. Okay, this is the, I don't know, I don't remember what you're doing, what number? Oh, it's 16, no? Okay, to say I know que P is 1 and Q is 5. And the formula is plus or minus P divided by Q. 1 is 1. 1 is just 1, plus or minus. I consider two possibilities. And 5 is primary, so you consider 1 and 5. Our list would be 1 plus or minus, of course, and plus or minus 1/5. End the story. Two possibilities. Oh, nice. I like that. It's the option D. That one. Okay. Continue. 17. Oh, 17 say using the rational zero theorem to find. Okay, everything is right. Giselle Perez. Okay, Giselle. The most important for me is that you learn, and the only way to learn is working. Okay, that is the reason I create this homework. I create. When I saw one student, I check the homework. The homework is not mandatory, but when I see that some students don't do the homework, I understand. Maybe you are brilliant, but you are lazy. Okay. Okay. Now, suppose 17. 17 question is different. It's more complicated. F of x equal x to the 4th power plus 24 x to the 2nd power minus 25. Ooh. And what they want? They want using the rational zero theorem to find all the real zero of the polynomial function, using the zero to factor f over the real number. Okay. First of all, I investigate what is the p, what is the q. P is 25 and q is 1. So plus or minus p divided by q, que es 25. 25 plus or minus 1, plus or minus 5, and plus or minus 25. And 1 is 1. The list of the potential are 1 plus or minus, of course, plus or minus 5, and plus or minus 25. I need to investigate. Because one possibility is doing scientific division, another possibility dependent. Remember, you have two tools and you complementary these tools. So what is the goal of the scientific division? Factorization. But factorization without the classical factorization that we studied in college. It's a new. Entonces you complementary. So one problem like that, que es easier, because it's trinomial. Look. Oh, 25, sorry. The factorization is piece okay. You open to parenthesis. Square root x to the 4th power is x to the 2nd power. And the combination to open the door is 25 and 1, no? Because 25 times 1 is 25, and somehow 25 minus 1 is 24. Of course, this is positive and this is negative. Okay, I finished. No, I don't. Why no? Because this is irreducible quadratic. I know that the factorization in the real field, sorry, is impossible, this factor. However, this yes. because it's subtraction. It's x 1 plus or minus. Therefore, this is the factorization. However, they want more. They want the real, no? The real zero. And the real zero is obvious, que es -1 and +1, que es this and this, equal to 0. This is not. This is complex. So now the answer is the option D, I guess so. Because the actual real zero are -1, +1, and the factorization look like exactly the same I am doing here. No necessary scientific division, at least in this problem. At least in this problem.
Professor.
Go ahead.
How do you change 25?
How you change what? Well, repeat the question, please.
How did you change the 25?
Okay, I don't know exactly what is your question. I understand the. No. The microphone is clear, but the idea is not clear for me. So, do you want to explain from this to this step?
Yes.
Okay. No. This is a classical factorization trinomial, mister. So you have trinomial 1, 2, 3, 1, 2, 3, trinomial. And the factorization of trinomial, you open two parentheses because it's two binomial. Did that. And try to find the combination that open the door. The combination that open the door for sure is 25 and 1. Because you need to find two numbers that multiply each other. Give me 25. And addition or subtraction, depending on the problem, give me 24. So the combination is open the door, two numbers, I don't have idea, multiplication, give me 25. And this number, the same number, plus or minus, give me 24. And the combination obviously is 25 and 1, because 25 times 1 is 25, and 25 minus, no plus, we have two possibilities, is 24. That means that 25 is positive and 1 is negative. This is clear? This is your question?
Yes.
Cool. Entonces now the most important, at least for me, is why can you reduce the 25? This is important. Why you cannot? Okay, this is the most important question. Look, why no? Why no? You cannot break it down. You nice break it down this into XX 1 plus or minus, no problem. However, this no, why no? Because suppose you take the sum of a square and you enforce it to be 0. I want to investigate what's going on. So x squared is equal to minus 25. Apply square root both sides. Wow, the answer is plus or minus I phi or phi I. Let me write in the proper way, because the square root negative 1 is phi I. So actually, actually, I mean, look, you can. The answer no is not totally true. You can break it down like that, xx, phi I plus or minus. But this is not important for us because the problem is talking about real. What is the real part? The real part is the part can contain negative. Negative indicate real. Positive no. Positive is complex. This is excellent question. This is a question I want to hear. Okay. Okay. Entonces 17 we did. 18. Let's do 18 now. It's another page, no? 18 now. Let's see the other page. It's 24. I suppose it's this. Guys, if we have no time to finish, sorry. Okay, next time, so next Wednesday, we start chapter 2. Okay. 18 is, well, This is complicated because it's impossible doing by the regular factorization that you know in college algebra. No. Well, okay, but however, I take the famous plus or minus p divided by q, ps6. I don't care the sign, remember, it's plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And q is 1, this is plus or minus 1 only. Our famous list of the thing I try is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And I need to start investigation. What is the value can give me 0 remainder using synthetic division? Okay, let's do it. So I have no idea at the beginning. Okay, you are a smart guy. Listen now. You are my student, and my student the best, always. You before doing this, and don't waste the time, coño. You put in decimals. In decimals, you see clear what is the real positive or negative. 0, and you start doing synthetic division, no, in arbitrary 1, positive 2, no, you go directly to the point and you prove me algebraically. For example, in this example, 1, 2, -5, and -6. I put in decimal, I saw that 2 work perfectly because it's 0. Bring down 1, multiplication is 2, 2 plus 2 is 4, this is 8, subtraction is 3 positive, and 6, 0 remainder. Boom! Therefore, the factor x minus 2 belongs to this polynomial, and the 0 is at value 2 positive. And also I saw in decimals that -1 also worked. Bring down 1, -1, 3, -3, 0. Another factor is the factor x plus 1, completely opposite sign. So you see negative here, it's opposite in the factor. And the 0, no, 0 is the same. And the last factor, remember, our original polynomial was degree 3. When you perform the first synthetic division, reduce degree 2. When you perform the second synthetic division, the degree is 1. Therefore, this quotient is x to the 0, x to the 1, and you don't need to do anything because the factor is x plus 3. Is x equal minus 3. Entonces, what is the question? I am lost. They want the real positive, the real 0, que es, you determine que es the option D, no? Option D, look at that. Option D, que es -3, -1, and +2. -3, -1, and +2. And the factorization, the factorization is easy. The factorization is, you copy the factor, it doesn't matter the order, x minus 2, x plus 1, x plus 3, and finish. I guarantee you, if you go backward, so you multiplication, you FOIL, you pick 2 binomial FOIL, and you pick another binomial FOIL again, 2 FOIL, you get exactly the original. It's the inverse process. So the inverse process is easy, it's multiplication. The complicated problem is the factorization. Break it down. Do you understand very well or not? Okay, cool. You consider it was useful continue in the same order, or I skip something in order to cover more possibility, no? For example, 24, 25, and 26 is different. 21, 22, and 23 is the same. It's the same, no, it's easier. Because you determine the zeros, the real zeros. Shane, look, let me advise something. 20, same stupid thing. 21, 22, and 23, no, it's different, but it's easier. Because you determine only one part, it's the zero, the real zero, and not necessarily factorization. Okay? However, 24, 25, and 26 is a little bit weird. So I would like to explain this right now. Because it's giving one polynomial. Look, it's giving one polynomial, no, one equation, polynomial equation, of course. It's giving one polynomial equation. It is giving one interval. I want to investigate 1, 0, okay, by the way, decimal weird, and between this interval. But this is super easy because you are doing in decimal. I want to show you how now. Let me try to share decimals. Okay, decimals, specific decimals. Okay, yeah, there you go. It's this guy. Do you see decimal now? Entonces we are talking about.
Yeah, we see it.
Yeah, cool. We are talking about question 24. Question 24. Question 24, 25, and 26. It's weird. Very, very weird. Look. So you put in decimal like that. Look, 24. I just copy the polynomial x cubic minus ax minus 3. Guy, by the way, you can put it here to start decimals. Let's do it sometimes. You put y equal. You omit the y. Decimal understand very well. Okay, this is y. This is totally non-necessary. It's irrelevant. Another possibility you write is using function notation. No? F, you put an egg, you want Maria, Jose, f of x. Utilization of the function notation is because you want to evaluate. For example, you in another part of the problem, you evaluate in 2, x, so you replace 2 here and give me a number. So you're using like a calculator. But no, not necessarily any y, ni nothing. This is totally not necessary. However, you put the curly bracket and your specification. I want to do without that part and with that part. The specific, the interval I want to see only this piece. Look, let me show you. Bang. So we see now the total graph of the polynomials. One piece of the graph of the polynomial. Obviously, if you want to understand or find the 0, you click on the curve at any point, and you see one gray point that is important, and this is the 0. The answer is minus 0.32 or minus 0.32. Depends if the round is 2 decimal place or 3 decimal place. Normally, decimal round 3 decimal place. But no, and the test is only 2. However, if you omit that part, let me show you if I delete that part. No, delete totally. I want to control X, que es cut. Entonces, when you cut that part, you see the completely polynomial. Look at that. This is a completely polynomial. Wow. And this is typical third degree polynomial because you have 2 turning points, 1 and 2 turning points, and we have 3 0. 1, 2, and 3 0. By the way, is what were they supposed to do on decimal from the week? Ask me the question because I don't understand in the chat. You say something in the chat because it's important. All right, let me see the chat. All right, chat. I don't see a question, no. Activate the microphone. What is your question? What were we supposed to do on decimals from the last week email? No, nothing. It's to see. I sent to you that you see what is my style to organize the function, the example. You're doing it your own way. This is the beauty. The beauty of decimal is que es very, very intuitive. So everyone open decimal, everyone doing something. Okay, no, nothing. I sent to illustrate something. Pero no. So do you understand the idea for this question or no? Entonces when you specification the interval, let me show you now magic. This is sign feature. Control P. I see one piece specifically in between -1 and 0. Y es the part que I want to investigate in the story. You determine the 0 que es negative 0.382. Que es the option C. Do you see the option C in the handout? Let me come back to the whiteboard. Oh yes, look at that. Let me share now the whiteboard. Off. Okay, no chat anymore. Switching to whiteboard. Okay, there you go. Okay, do you see whiteboard now? All right, let me see. I suppose that the answer is this, no? Negative 0 point is D. I copy in my paper C. C is positive, no? It's negative. D. Guys, do you understand or no?
Yes.
Okay. Okay, let me try. Entonces, 25 and 26 is the same, no? 27 is nice and important. 27 is nice and important. So we need to obtain a polynomial que degree is 3 and it's given 2 zeros. Yeah, actually I know that we have 3 because degree 3 zeros, but it's given 2. Okay, because they are bad guy. So now the factorization is x plus 2 because the 0 is minus. And we have another factor que es x minus 3 minus I because the 0 was negative 2, another 0 is 3 plus I positive. Of course, when you put in the format of the factor, remember the factor format is x minus a. And A represents the 0, no? Si es minus, double minus, become positive. And here is positive, become everything negative. But we have another case, the conjugate, que es this. Because you need to know the concept behind this idea is the complex is coming by a pair of conjugate, husband and wife. Another factor is x minus 3 plus I. And this is the factorization. This is our polynomial, third degree, 3x, 1, 2, 3. But I feel no, I need to multiplication and that's it. Let's do this. It's the last question I solved today. This is easy because you foil. Let me try to do x times x is x squared. X times this is plus minus 3 plus x, sorry. And this time this is minus again, minus 3 minus I, x. And this together is the last foil. First, outer, inner, last, no? Is plus minus 3 minus I plus minus 3 plus I. Okay, entonces I do the complicated part first. ¿Qué es this? This multiplication, again, another foil, que es 9 minus 3i plus 3i and minus I squared. This cancel, say goodbye. I squared negative 1, another negative in the front is positive 1, so the answer is 10. It's expecting. When you multiply any complex number times its conjugate, the answer is real. And the shortcut to do super fast is to multiply 3 times 3 get 9, and 1 times 1 gets 1, and you always plus in between. Now x squared minus 3x plus ix plus 3x plus ix plus 3. This is cancel out. Say goodbye. No, something is wrong. Something is wrong because the cancel out is always. A ver. The complex part is cancel out. A ver. I suppose I make a mistake here. Okay, let me organize this more elegant. Look. X plus 2 bracket x minus parentheses 3 plus I. Close the parenthesis is the second factor. The third factor is x minus 3 minus I. Cool. Close the parenthesis and bracket. We're doing the multiplication of the bracket first, que este complex. Entonces, x squared, this and this x squared minus 3 minus I x. I did this multiplication and this multiplication. And this multiplication is minus 3 plus I x and plus. I did that part, que thing. Yes, I did well. That part. Now. I have x squared minus 3x plus ix. Minus 3x minus ix plus 10. Es obvio que the I disappear. Because the reason is clear, because you have a polynomial que the coefficients are real. No I anymore. So now the I part disappears. So x squared minus 6x, because negative 3 and negative 3 together is 6. And finally, I don't want to delay more. You multiply x plus 2 times this. Guess easier. This is a piece of cake. I have in my paper, the answer is x to the 4th power minus 3x cubic plus 5. This is elementary algebra. Square minus x minus 10. Okay, and this is the final answer. Okay, corresponding with the option C. Okay, guys, that's it. Good luck for the test. Remember, our day is May 29. Submit online. Send me email. If you don't send me nothing, I put 0 in Canvas. Okay? Any situation that you have, emergency, you let me know. My pleasure, anytime. I am here for you.
Professor.
Go ahead.
Quick question. For the Alex test. That's all. That's what to take.
I don't understand.
All right, the online test is the Alex test. Is a test that's on Alex, correct?
Yes. So in the Alex, you see 3 homeworks and 1 test. Yes. And any chapter contains 2 tests. 1 on reading and 1 in online. And both are important. Suppose que some students, you know, have no clue, believe que pass the class, you take the 5 tests on paper. No. This is 50%. You take the on paper test and you don't touch Ale, you fail the class. So Ale is super important. It's 50%. 50-50. ¿Es clear the idea, mister? Any other question? Okay, so I expect that you are doing well. Bye-bye. I have a question, email me. Any question, you email me. I cannot hear. You email me, you make a screenshot. I explain. Say, email me.
Both tests, someone in the chat asked, are both tests due on the 29th? The one on Canvas and paper?
Yes. The answer is yes. You have some situation or no?
Oh no, I'll just no. Someone in the chat had asked that question,
Yeah.
and someone else in the chat had asked, "How do you find p from Descartes' rule when monomos aren't in order, like x to the fifth power plus x squared plus x?"
Mister, email me. I don't. Do you believe I can copy this in the piece of paper? No, this is not correct. You make a screenshot. Send me. You know how you make a screenshot in your computer? Yes or no?
Yes.
Please send me by email. I reply with the answer. You see que fantastic this procedure. When you see the first time, you see, wow, amazing. Email me. Any question? Email. Thank you. Bye bye.